So in number 23, so this is a special type of a triangle. Because we can combine to the Pythagorean right triangle to make this triangle. All the side length are integer. So if we use such property, what I'm saying is we can divide this base 14 into two parts. The first part is 5 and second part is 12 and 9. In such case, the altitude of this triangle, the AD is 12 because 5 squared plus 12 squared is 13 squared, and 9 and 12 also make 15 in Pythagorean triangle. And then DE is perpendicular to AC. And AF is perpendicular to BF. If D is at the origin, the slope of AC is minus 4 over 3, and because D is perpendicular to AC, the D's slope is 3 over 4, so we can make the equation of the line for DE. Like this. And then we can make a circle with the diameter of AB. When you do that, these two right triangles, the F and D is on the circle. This type of circle, we can make. Because in the case of a right triangle, the center is located at the midpoint of hypotenuse. So if we make the equation for this circle, the center is the midpoint of AB, and that means the center's coordinates are minus 5 over 2 and 6, and because D is at the origin. And the radius is the half of 13. So the equation of the circle is a square is this. And to find the coordinate of point F, we can change this y to this 3 over 4 times x. And one of the x value is 0 because this x coordinate is 0. So if we open these squares, yeah, the constant cancel. And we can also cancel one of x's. That means yep, so this is the x coordinate of point F, and we want to find the length of df. And when we make a right triangle, like this, because the slope is 3 over 4, if we want to find the hypotenuse of this green right triangle, the base length is 60 over 25, uh, so the ratio is 4, 3, and 5. So that means the length of the f is this x coordinate times 5 over 4. So if we simplify this, yeah, that's the length of df. And what's the sum of the numerator and denominator? Yeah, can you hear me? What's the sum of 16 and 5?
21.
21. So the answer is 21. So in this problem, if there is an integer m and it has 4 factors, and that means M is P times Q, and P and Q's are prime numbers. In such case, this integer M will have 4 factors, and when we add these 4 factors, that will make the sum will make the n positive integer n. In such case, the n is called the nines. So if we add the factors of m, that will make the nice n, and this means if we use factoring, n is the product of p plus 1 and q plus 1. So the first case we can think of is, let's say one of these 2 prime is 2. So let's say p is 2. If p is 2, n is the multiple of 3. So from the set, we can choose the multiple of 3's. So candidate for n is these numbers because they are the multiple of 3. So that means if we divide each n by 3, because p plus 1 is 3, the q plus 1 is this. So that means because q should be prime number, this doesn't make sense because in such case q is even. So is 669 prime number? 669 is not a prime because that's a multiple of 3. How about 671? Is 671 a prime? Yep, 671. Is this a prime number?
Yes.
Okay, actually that's not a prime because it's like 61 times 11. So unfortunately this is not a prime. So that means the first case there is no number satisfying the prime number 2. So that means we can think of the second case. Second case means if one of the prime is not 2, that means except 2, all the others are the odd numbers. That means the p plus 1 is even number and q plus 1 will be also even number. That means if we multiply two even numbers, n is a multiple of 4. So for the second case, we can check the multiple of 4 from the set. So there are two multiple of 4 from the set. And for the first number, so if we divide each number by 4, we have these factors. So let's say p is 3. P is 3. In such case, the p plus 1 is 4. But for the first case, that means q plus 1 is 503. So that doesn't make sense because q is odd number, so q plus 1 should be the even number. So this is not the case. And for the second case, once again, let's say p is 3, so p plus 1 is 4. That means q plus 1 is 504. So in such case, q should be 503. So is the number 503 a prime? So 503 is a prime number. So that means it satisfies the condition. The p is 3 and q is 503. So there is one number satisfying in this condition. So one number is nice. So from the set, there is only one number. Yep, so the answer is 1. And for the last number, so we want to change a 3-digit number n to the number with the base 5 and base 6. And for the last digit, a multiple of 30 will have the same last digit when it's changed to base 5 and base 6. So let's think of the smallest multiple of 30, 3-digit number. So the smallest 3-digit number, 3-digit multiple of 3 is 120. So let's see what happens when 120 is changed to the base 5 and base 6 representation. So if we keep dividing 120 by 5, if we use this remainder backward, this is equal to this, it is 120, because 4 times 5 squared is 100, and 4 times 5 is 20, that makes 120. And how about 6? When 120 is changed to the base 6, the representation, and that will make 320. Yes. And then that's what Bernardo did. And Leroy, think they are the just normal number, so he added these two, and that's the sum of s. So when you just add these two numbers, s is 760, and we wanna compare this to 2 times n, and in this case 2 times n is 120 times 2 is 240. And we want to find the case when these two numbers have the same the rightmost two rightmost digits. But this case, because 6 and 4 are different, 120 is not the number we want. But that's the kind of process what we are doing. So let's try another multiple of 30. And the biggest multiple of 30, a 3-digit, is 990. So from 120 and to 990, there will be the 30 multiples of 30, because 900 divided by 30 is 30. So let's check all the multiples of 30. Yeah, so what I can do is so I'm going to look at this this part, the second digit. So and twins, this second digit is 4. That is 120. And the next multiple of 30 will be 150. So if we add 30, 30 means because 30 is 25 times 5. Uh, in terms of this base 5 representation, it's like adding 1 to this the second digit. But because of 5 should go to the next level in base 5 representation, it will be 0. And then the number will increase by 1. And how about the base 6 representation? Because 30 is the 5 times 6, that means for the second digit, uh, it will increase up to 5. But this means because we are using this base 6, adding 5 is like subtracting 1 because it cycles with 6. So we can subtract 1 from this the second digit. And in terms of 2n, 2n is adding 60. So 60 means the 10th digit will increase by 6. Uh, so, so once again, adding 6 is like subtracting 4 if we use base 10. Yeah, so this 40628, they repeat. And we wanna find the triple. The sum of the first two makes the third number. So in this case, uh, this one, 2 plus 0 is 2, and 3 plus 5 is 8. This one. So there are 5 cases. So uh, let's just say one of the case as an example. So if we keep adding 30, the first case happens when we use 360. So let's change 360 with base 5 and 6. Yep, so with the 5 base of 5, the number becomes 2420, and if we use 6, the number becomes 1400. So if we add these two, the essays, and 20s, 360 times 2 is 720. Now we have this, the same, the two rightmost digit. So that's why it's the case we want. And then let's change the last digit to 1 from 0. So if we change this to 0, if it's 1 from 0, they become 1. Because 1 plus 1 is 2. And 361 times 2 is 722 still. Still we have the same two rightmost digit. So we can change the last digit from 0 to 4. Because the 4 plus 4 is 8. I mean, when it becomes 5 now, we need to change it, the base 5 representation. So that means for each triple, there are 5 cases, and there are 5 triples. So what's the product of 5 and 5? Yep, 5 times 5 is
25.
25. So the answer is 25. Yep, so that was 13B.